So where we stopped the other time, let me quickly share my screen. So Shiju was asking a question that I didn't, just like the way over here when I added value to goods here, added a fresh value, I used index. This is indexing. I use indexing. Now, over here, I did two things actually here. What I did here was that the first thing I did is this line, I edited what I have in the first index here. And this other line, goods.append, added a new element to the list. So now this particular one, which is editing what is in the list, editing what we have there, is actually that mutability, that spirit of mutation that is in list. But in set now, I can't actually edit the index. I can't edit the index. I can't say I want to come and change what is here, because set in itself is actually an unordered list, so it has no order. What is just after is to ensure that there's no duplicate of values. So if we can see the way the output is not even ordered. It started with Olawumi 247. Then if we even now put the Kolapo, which was the last thing I added, I didn't think this was list. Kolapo would have been behind Jonathan. So set in itself is an unordered list. So, and it definitely does not have anything to do with indexing, which was what I did here. So the only way to add an element to set is by using this add. There's no way I can't do what I want to write now. If I do password, then I try to do what I did that time, and I did 0, and I try to say, that means I want to change Olawumi 247 to maybe Kolawole, and I run this. There will be an error. As you can see, it says set object does not support item assignment. So I can't assign a particular index again that has already been assigned. I can't edit it, but I can actually add a fresh value to it. So I don't know if I actually answered the question, sir.
Yes, you did.
Okay.
Thank you.
So let's briefly move into the second session. That's operator. So there's what I already prepared also for operators that will explain it better. So operators, there are various kind of operators we have need to use as we progress. Now we are familiar with mathematical operators like plus, minus, division, addition, and many of them like that are mathematical in nature. Now those operators, they can only work in a programming. They can only execute a mathematical let me complicate it. They can only do mathematical operation. That is, I can't add Shola plus 22. Although there's a way that one can work, we will still get there. When we are dealing with strings, we can actually add two strings together using some mathematical operators. But talking about arithmetic operators now, we can actually make use of them when we're working in programming. Take for example, so these are the operators. Now, looking at arithmetic operators, which is the first one, this is just the basic of mathematical operators we know, plus, division, addition, subtraction, and there are few quite of them that are added to it. So let me just start with the arithmetic operator. Now, as it is now, I've declared a variable called A to be 34. I declared B to be 56. Now, the sum of the two, I added it up together using the plus. So what I will do is we add the two values together. And I should be expecting 90 as a value. So I can decide to then print my C. If I run this now, I will have my output here 90 as the output. So I can actually do some other mathematical operators. I can say D equals A minus B. Then I can go ahead and do maybe E equals A divided by B. Then what other one? Okay, then I can do F equals A times B. That will be a bit large. So now let me print out everything. So let me just print it out in and print C, D, E, F. So let me print it out. So as you can see, C is 90, that's A plus B. Then A minus B, that's 34 minus 54. Very smart. It knows that B is actually, A is actually less than B, and it did it well. We have minus 22 as our answer. Then E, A divided by B, that's 34 over 54. That's a proper fraction. So we have something less than 1. Then we have A times B, that's 34 times 56, and we have this. So there are other arithmetic operators that I would like to introduce us to. And in the course of our work, we will see where we can apply them. Now, for those of us that are familiar with binary division, you know, when we are converting we are trying to convert a 10 base 10 now. We're trying to convert a base 10 to base 2 now. Yeah, there's a way we were being taught then in primary school. We draw a line, they'll do 2, maybe if it's 10, 2 in 10, 5 remainder 0, 2 in 5. Now, when you want to do something, you want to divide something and you want to get the remainder, there's what we call modulus. Modulus is an operator that what it does give you is it gives you the remainder. It's going to divide it up, but what you will have as an output will be the remainder. So let's take, for example, we have let me create a new variable. Let me call this one first digit. That's wrong. First digit. Then I will call first digit to be 5. Then I will say second digit. And I'll say to be 2. So now, if I do 5 divided by 2, the remainder definitely will be 1. So I can say, let me store the remainder inside a variable called REM. Then I do REM. All I'll just have to do is just do 5. Then the modulo sign is a percentage. It's a percentage. So 5 modulo. That's what they call. That's where it's being called. They don't call it percentage. They call it 5 modulo 2. So what is going to give me is the remainder. So I can then, if I can go ahead and print REM. That will be the remainder. So let me comment this out so that we can see. So shift enter. So as you can see, the remainder is 1. So let me try another value. Let me say I'm trying to divide 7 by 5. So I should have a remainder called 2. If I do that, as you can see, that's the remainder. That's what we have. So that percent, that modulo, it's being called modulo. That modulo is a mathematical operator also in programming. Also, another mathematical operator is exponentiation. Like maybe you want to put something raised to power something now. There's a way we write it in Python. Say, for example, I want to do 2 raised to power 5. Then I can just say, let me create a new variable. Let me call it third digit. Then what is third digit? Third digit is equal to doing exponential, that's 2 raised to power 5. So I can do second digit. So it's a long variable. Instead of me writing it I can just press tab. So I should see it there. So second digit, then I want it to be raised to power 5. So I'll do star star. That is how we do exponential. So star star first digit. So I'll do tab. So now it will store the That's 2 raised to power, come in. That's 2 raised to power 5. That's what it's going to do. Then I can print it out. So that should give us something around 32. So let me print third digit. So shift enter. So as you can see, let me comment this out. Then let me enter again. So as you can see, we have 32. So that's for exponential. So now the last one I will talk about in mathematical operation is floor division. Floor division is a situation whereby you want to divide something and you don't want it to give you a decimal value as output. You don't want it to give you a decimal value as output. So how do I do that? Take for example, when we divided 5 by 2, when we divided 5 by 2, if we divide 5 by 2, definitely we came up with a remainder. Let's say remainder 1 now. Now, I want to divide 5 by 2 evenly. I don't want any decimal value. I don't want any remainder. Just give me the whole response. So now, what I'll do is let me create a fourth value, which should be a variable, fourth digit rather, fourth digit equals, then I'll make it 5, they'll call it floor. That's 2 slashes, 2 backward slashes. That's 5 floor 2. Then if I now print the fourth, I print it. Let me comment this out. If I print it, shift enter. So as you can see, 5 divided by 2 will give us 2 remainder 1. See, it's not even giving us now. If we do that by using calculator, we have 2.5. But when we do a floor division, it gives us the whole number. It won't even approximate it. That's it. It won't approximate it. So that's floor division. So we've looked at the various mathematical operators in Python. We have plus, we have negative, subtraction, we have division, we have multiplication. Then we have the modulus. We have modulus. We have exponentiation, and we also have floor division. So as time goes on, we see need to do it. Maybe when we begin to apply some data science libraries, and maybe you are calculating the mean. Take for example, let's do something very, very simple. Let's say we created a list. Let's say list of score. We are familiar with list now, so I'm free to do that. List of scores, and it's just list of scores, and we have it to be 4, 5, 6, 8, and just like that. And I want to find the mean. I can actually do it in a way. Let's say my mean equal to, we can do it this way. Let's say list of scores dot sum. So now, sorry, come in. So let me make use of something. Let's not worry with what I want to do. I just want to let us, all what I'm writing we'll get to understand later. So MP. Okay, come in. Now, I want to explain something to us. Now, my cell is experiencing something that our cell may experience. Now, I don't know if you can see this, I don't know the name they call it, this symbol we are seeing over here. anytime a cell is executing some lines of code and it's taking time, maybe it's trying to do a work that will definitely take a time. You will see, if you see this symbol there, that means I don't know, for those that used to watch, those that used to fight, when two people wants to fight, they will put this jars of sand. So at the end of the sand, at the one the whole thing is done dropping, then the fight is over. So that's the same concept they applied here. So as you can see, it's still trying to execute what I've done. I actually ran this particular, I executed this cell using Shift Enter. So it's trying to do something that is quite heavy. I asked it to do import numpy as NP. Import numpy as NP is actually a library, a data science library that was still. So it avails me the grace to just add any list easily. So as you can see, it's done. The symbol has changed to the solve. So it took a little time because it had to import that library from the internet. So now what I did was, as I imported the library, and I made use of the library. And don't worry about, let's not worry about that now. All I just wanted to explain is, we see how list makes life easy. We have set of values inside list of scores, which is a variable. And with just a single line, just run sum. Oh, that's not the mean. Okay, now let's now find the mean. That's not the mean now. I can now do the mean by saying whatsoever is the sum whatsoever divided by, I have how many elements there? I have 1, 2, 3, I have 8 elements. So I can divide it by 8. So that will actually give me the mean. So the mean here is 6.375. So our mathematical operators define the application in virtually all that we'll be doing. If we are evaluating standard deviation, if we are doing anything, it comes into play. So let me just erase all this because we don't need them now, so that we won't disturb ourselves. So it's just to explain to us that the mathematical operators will find application in all that we'll be doing. So that's concerning arithmetic operator. And also, let me quickly explain something. There's what we call PEMDAS in programming. PEMDAS. PEMDAS is the order of operation. Let me write it out. PEMDAS. PEMDAS. What it means is the P stands for parentheses, the E stands for exponential, the M for multiplication, the D for division, A for addition, S for subtraction. It tells us the order at which the computer evaluates any mathematical operator. Imagine I write something in this format and I call it var. I call a variable var equals, and I open a bracket and I say for, okay, let me write the quadratic equation now. If I want to evaluate quadratic equation now, that's minus b star, that is multiplication. Then I need to do square root. That's okay, minus b plus, yes, there's plus first. That's, let me say, okay, there are two values that will come out. Let me say the first value, then that will be plus minus b plus, then I need to do square root. Now, for me to use to do some key things in some mathematical operation, I need to import a library called math. So that's what I'm doing here. Okay, so math.sqrt, then I'm doing the square root there, square root b squared. Now to do b squared will be b star 2. We know that minus 4ac, that will be minus, then my 4ac is a multiplication. So I'll just open the new parentheses and do 4 star a star c. So we know star here is multiplication. This is what is going to, so we can't do 4ac. Computer does not understand that. We will just be thinking 4ac is a variable, which is even wrong in itself. So we are trying to do a mathematical operation. So we have b squared, which is this, minus 4ac, which is this, then the square root of the 2. Now everything all over 2a according to quadratic equation. So I want to do everything all over 2a. So I'll close everything with parentheses all over 2 times a. Now, what I'm trying to explain concerning PEMDAS is, now, if the computer sees a formula, an equation like this, how is it going to execute it? It's going to execute it from inside out using this order of PEMDAS. Now, what's the order of PEMDAS? Parentheses for. So it will go inside. What is the smallest parenthesis? Which is this? It will evaluate it. Then it will represent it with a single value. So this is what it will evaluate first. Now I'm explaining how the computer will evaluate this line now. So it will evaluate the smallest parenthesis first, and when it's done that, represent it with a value. Now let's say the value is 42 now. That means 42 is staying here, and I have b squared minus 4ac. Now what other thing now? It will still try to evaluate the parenthesis that is now outside of it, which is now what I'm highlighting here now. So now, when it gets into that one, it will now meet b squared minus 42. Now, how will it evaluate it? It will now still go back and use the order of operation. Parenthesis, it has already entered the parenthesis. The next thing is exponential. So, is there any exponential in this room? Yes, exponential. We have b star 2. So, it will evaluate b star 2. I say b is 2 now. That will be 2 raised to power 2. That's 4. So, okay, I've evaluated that. Then, is there any multiplication? No multiplication. Is there any division? No division. Is there any addition? No addition. Any subtraction? Yes, there's a subtraction. So, it's going to go ahead and do, that will be 4 minus whatsoever it has first evaluated there. Then, it will now represent all that we now have here with a single value. So now, what is now the next thing? The next thing now is to do what is outside here, to now find the math.sqrt, that's the square root of whatsoever single value it has done. Then when it's now done, to now get into this outside parenthesis, I will now do minus b plus whatsoever we get now. So let's just repeat this for the second value. Control Z, copy. Second value. So let me call this second value. So in this case now is minus b minus. So now so now I need to declare some value. I don't want it to use the values I have here. Let me use okay, a equals 4. So we are assuming a quadratic equation now. A equals 4, b equals 7, and c equals 3. So now let me run this. Let me comment this out. So let me run this line. So now it should print out. Let me say print first val, then print second val. So let me run this cell, shift enter. So now, very fast. So now it's done, it's evaluated it. And we have our output here. Our answer is minus 12 minus 16. So that's just an example. So let me call this example. So let me call it example. Okay, so that's that. So that's concerning just one out of many applications where we can apply arithmetic operators. So another operator is assignment operator. This one is a bit trickish, but it's very, very, very simple. A bit trickish, very, very simple. Let me correct a bug here. Plus operator. Okay. Plus operator. Okay, so take for example, you can just see what I highlighted here. I want to do b equals b plus 3. Now let's take note of something. When it comes to computer thinks from behind. It thinks from behind. Now human being reads from the front, computer reads from behind. So it's the basic rule of programming. It thinks from behind. Now I want to do something like this. Humanly speaking, this is not reasonable. Now, following the foundation understanding that computer thinks from behind, what I want to do is I want to add 3 to the existing value of b. Now, B here is just 6 over 2, which is 3. Now, I want to add 3 to B. That means I want to add 3 to 3. Now, I now want to store it inside B itself again. Yes, it's possible with programming. You can actually do that, where you, due to that ability of computer to think from behind. So I will add the present value of B. I may add a fresh value to it, and I'll still save it inside the same variable. So assignment operators help us to do this very, very easily. Now, what I have here is the same thing that I've done here. So B plus equals 3. What I mean is add the latest value of B, add 3 to it, and store it inside B. So this line is the same thing as this line. So as time goes on, we will see where we may need to apply this. So this is an assignment operator. So let's assume what you want to do is division, not just addition. Just change the plus signal there to division symbol, and it will do what we have here. So we can actually run this now. If we run this now, at this point I printed my B, which is 6 over 2, which is 3. You can see the output here. Then at this point I printed the fresh B. The fresh B now, 3 has been added to 3. That's 6. We have what we have here. Then the last one now, I divided whatsoever the value of B is, I divided it by 3, and I stored it inside B again, and I printed B. And that's B was maintaining 6 here. Then 6 divided by 3, I have 2. So that's assignment operator. Then let's move on to comparison operator. Now, as time goes on, you realize that programming is very, very simple. It's just comparing two things with two things, and or just understanding how things work and putting it to use. And we need to maybe want to compare one thing with the other thing, and there are operators you use to compare. Now, if you look at this cell now, I have A to be 4, I have B to be 7. If I want to compare if A and B, if maybe A is greater than B, A is less than B, A is less than or equal to B, A is not equal to B, there are operators I use. Take for example, don't mind some syntax, just look at the functionality. If I say if A equals B now, if A equals B, then print So if A equals B, now if you see now, I use 2 equal sign. So this one is not just assigning now. We use equal sign to assign here. This when you use 2 equal sign here, you are not assigning, you are now comparing. So what I'm comparing at this point is if A, the value A carries, which is 4, is equal to the value B carries, which is 7. If that condition is satisfied, come and do what I have here. So we will later understand how to write this conditional statement. But I'm just trying to explain to us that we use the 2 doubles equals operator to compare 2 things together. So if I run this cell now, if I run it, let me run it. Okay, now, as you can see, it's not giving me any output. Shift enter, no output, because A is not equal to B. Now, let's change the value of B to 4 and let it be equal. Then I run it again. As you can see, we can see the output. At this point, the condition has been satisfied. Now, what if I want to do maybe A is greater than B? So I can do A is greater than B. If A is greater than B, do this, which is not true. If I run it, no output, because A is not greater than B. A is 4, B is 4. Now, if I want to do A is if A is greater than B or equal to B, all I just have to do is just add the equal sign. That will match 2 conditions for me. If A is greater than B or equal to, if I run this now, as you can see, it gave me an output because the second condition was fulfilled. A is equal to B, but A is never greater than B. So we have 10 minutes more. Let me just quickly rush through. So there are other comparison operators that I've explained in these comments here, and if we check them online. So maybe if I want to check if A is not equal to, if it is not equal to B, print it. No, it is equal to, so that condition won't be fulfilled. So we can do it on practice some other comparison operators. Then there's another operator that we use to match two conditions together. Now, if we look at this example I have in this logical operator now, I stored a variable, I created a variable called age. I stored the value 23 inside, and I want to check if age is greater than or equal to 23, and the type of variable that age is an integer. If you remember the other time, I explained that we can actually get the type of a variable by just saying type, then the name of the variable. So now this is a condition, and this is also another condition. So I use this AND operator to bring two conditions together. So if those conditions, the two are being met, then do what I have inside of here. So if I run this now, it's being fulfilled because age as a variable is an integer, and age is greater than is equal to 23. So now let me alter it. Let me change age to be 20 now. 22 now. So 22 is less than 23, and 22 is not even equal to 20. 22 is not equal to 23. So one of the condition is down. This condition, only this has been fulfilled. Let me run it. No output, because I've used this AND to match the two conditions together. So now a condition was fulfilled, another was not fulfilled. Now I can use the OR in case I want, if one side is fulfilled and the other side is not fulfilled, I still want it to do what I have there. If I press enter, it ran because this condition was fulfilled, the other was not fulfilled, but the OR logical operator give me that room. So, and there's another one called NOT. So I want us to check NOT on ourselves. So when you are doing NOT, you are trying to say maybe A NOT. Let me create an example. I say let me okay, if H, I say if type H say not so coming. Okay, so as you can see now, I made use of not here now. I said if not, that means I'm saying if the type of age, if it's not equal to string, print what I have here. So I barely make use of. So let's not be too concerned about how to write these conditions. What I actually want to explain to us is those operators, that AND, those OR, that NOT there, and the function they actually play. So we'll still get to a session where we explain how to make use of the conditions, all this if and all that. So let's not fret about that. So let's move to the second to the last operator, that's identity operator. So take for example, this one is very, very simple. If I say I have a variable called A equals 5, B equals 6, and I say A is not B, like I want to know if the value A is carrying is not the same as what B is. It's telling me that's true, but I run it now. But if I say A is, I'm asking a question. A is B. It's telling me no, false. That's not true. That's not true. A is not B. But if I say A is not B now, yes, you are correct. That statement is correct. That's just what the is and is not is used for. Then the membership operator. Take for example, you have a list. You want to know if an element is in a list. Like this example now, I have a list called STD score, and I have a new score, 34. I want to know if 34 is in that list. So I say new score in STD score. I'm asking a question. New score in STD score, if I run it, tell me false. It's not there. Let me change it to 45. Is 45 inside STD score? It returns true. So that's what that in operator is used for. And I can use not in, just like in reverse. Then the last one is a bitwise operator. What bitwise operator helps to do is, take for example now, you have A to be 60, B to be 13, and you want to run some binary operators. You know, this and, or, ZOR, for those that are into electronics, we know the significance, like this 60 now, it has been converted to digit binary value in this format now. What AND does is anywhere that one is not the same, just replace it with 0. Look at here and here now, 0, 1, 0, 0, 0, 0, 1, 1, 1, 1, 1, 1, 1, 0, 0, 1, 0, 0, 0, 0. So this is what A and B. The AND here now is a bitwise operator. What it will do for us is to perform that AND operation, to perform it on the binary form of whatsoever we are entering. And this other one is for OR, to perform the OR. Why this one is the SOR. So we may not really need all this, but just to get us familiar with it, so that when we see them, we are not surprised. So that will be the end for operators. I will push this. I'll push this code. I'll push it to my GitHub profile. I'll push it to my GitHub profile, and I will try and do something now. I will teach us how, if we see some people's code files, how we can, like I said last week, that the statement is called fork. That's what they call it, F-O-R-K. Maybe when you fork dodo and put it in your plate. Now, I've written this now. I'll put it on my GitHub account. I'll push it to my GitHub account online. Now, you can actually fork it and put it in your own plate. So when you fork it and put it in your own plate, it will appear on your own GitHub profile. So that you can also see the comments, so that we can also go through it. Aside the video that I'll be uploading, we can also see the code, and maybe we want to revise and all that. Maybe we are going to be familiar with the examples here. So I will do that. So we have 1 minute left. After this section, I'll quickly create just a 10-minute session that I will explain how we can fork codes from other people's repo to our own GitHub account. So, but is there any question before I do that? Any question?
No question, sir.
No question. Okay. Okay. Instead of okay. Okay. Can we? Let's try and log in back after this section for just a 5-minute section. So what I'll be doing is I'll be putting us through how we are going to fork people's projects to our own